Imagine for a moment a world where clean, drinkable water isn't something you just hope for, where it's not piped miles, but like pulled right from the air around you. Sounds a bit like science fiction, maybe. Well, today we're going to take a deep dive into a really fascinating scientific breakthrough, something that's actually making that idea a tangible reality. We're talking about a cutting edge device, and its inspiration is, well, pretty unexpected. Think nature, think music. It promises to seriously change how we access clean water. So, our mission today is to really unpack this. How does it work? What's the ingenious idea behind it? And crucially, what kind of global impact could this have? Especially, as places get hotter, drier, stressing our usual water supplies. It's a story of looking at nature, really, to solve a huge human problem.
Indeed it is. And the scale of this water scarcity problem, it's just immense. Billions of people are affected. You mentioned statistics earlier, and there was that science study. Over 4 billion people face severe water scarcity for at least 1 month every single year. That's staggering. More than half the planet. So yeah, this isn't just some neat gadget. It's tackling a fundamental global need. Health, economy, stability, it touches everything.
Wow, yeah. That really puts it into perspective. Okay, so let's get into it. The device itself. You said the design is unique, maybe even surprising. High-tech water harvesting
Yeah.
doesn't usually make you think of an orchestra, right? But that's part of the story here, isn't it? It's inspired by musical instruments and something else from nature, like at those huge California redwoods, the really massive trees. They live in foggy places, right? And apparently they get something like 35% of their water just from fog. Is that right?
That's absolutely correct. A huge chunk of their water intake. They're essentially harvesting moisture directly from the air to survive. It's this incredible natural adaptation.
Wow.
So, building on that, researchers at Virginia Tech, they saw that natural process, and they developed what they call a mesh harp hybrid fog collector. It kind of combines the best of both worlds, you could say, addressing old
Your
problems.
harp. Okay.
Yeah, and the musical instrument part, it's quite literal. Picture a harp, with all those vertical strings. This device uses a similar array, vertical wires, and their job is to catch those tiny fog droplets and guide them downwards. But here's the clever bit, the real advance. Like guitars need horizontal supports to keep strings spaced and taut. This device uses them too. These supports keep the wires perfectly parallel, evenly spaced. Seems small, but it's absolutely critical for making it work efficiently.
Right. That spacing sounds key. You mentioned it tackles flaws in older systems. What kind of flaws did those earlier fog harvesters have, and how does this mesh harp fix that? What did the support solve exactly?
Good question. So older systems, like simple mesh nets or even early harp designs, without those supports, they had big problems of clogging. Water droplets would build up, block the mesh, or make it sag, clump together. Not very efficient. And with the simpler fog harps, just vertical wires, they lose tension, tangle up, the spacing would go all wrong, huge gaps would form, and most of those tiny fog droplets would just slip right through, uncollected. Right. So the breakthrough with this mesh harp design, with those horizontal supports, is that it maintains this perfect uniform structure, keeps the wires evenly spaced, prevents that water buildup, that clogging. Water hits a wire, flows down smoothly, and the wire is immediately ready for the next droplet. It's designed for fog tiny droplets. Need precise capture, need efficient drainage, so you get continuous collection, not the stop-start, messy performance of the older ways. It's a big leap.
That sounds like a massive improvement. It really shows how looking closely at nature plus some smart engineering can lead to something pretty revolutionary. And you mentioned efficiency. This isn't just slightly better, is it?
No, not at all. The jump is dramatic.
Yeah.
There was a study published in the Journal of Materials Chemistry A. They did extensive lab tests, simulated different fog conditions, light fog, heavy fog, and the results, really compelling. The best prototype they tested, it captured up to 12.7% of the water floating in the air.
12.7%.
Okay, which might not sound like a huge number on its own, but compare it.
Right. Put that into perspective for us. How does it stack up against the old methods? Okay, get this. This new mesh harp. It's apparently 8.5 times more efficient than the traditional flat mesh nets people used, 8.5 times, and nearly 4 times better than those standard fog harps, the ones without the proper supports.
Exactly. It means for every drop an old net might catch, this thing catches over 8.
Well, it's a game changer for making fog harvesting practical.
It really is a paradigm shift, like you said. And it's crucial because, you see, those older systems, they just missed most of the water. The really tiny microscopic droplets just went straight through the gaps or past the clogged up mesh. This new design, with its precise spacing and drainage, it catches those tiny droplets effectively. So think about it practically. A square meter of this material in moderate fog could potentially harvest maybe 10 to 15 liters a day, enough drinking water for a small family.
From just 1 square meter.
Potentially, yeah.
Yeah.
With older tech, you'd need maybe 10 times that area for the same result. Much less practical.
Incredible. Okay, so we've got this amazing design, super efficient, but what does it all mean? For people, for communities, for the planet? Let's talk impact.
Right, the bigger picture. And that's where it gets really exciting. The whole point is for this to be practical and, importantly, affordable. That makes it ideal for places that really need it most. Remote areas, drought-stricken regions, places where getting clean water is a daily, exhausting struggle.
Places without reliable pipes or wells.
Exactly. Imagine not having to walk miles every day for potentially unsafe water. Having it right there, harvested locally and environmentally. It's a huge win. Think about desalination, pumping groundwater. Those methods use a ton of energy, can cause pollution, deplete resources. Fog harvesting, it's non-polluting. It just collects water that's already there in the air. Plus, it reduces the pressure on rivers, lakes, aquifers, helps local ecosystems. It's sustainable.
And the health benefits, that's massive too, right? Especially where infrastructure is weak. Safe drinking water is fundamental. This offers a reliable source.
Absolutely. Clean water prevents so many diseases, cholera, typhoid, the list goes on.
It improves lives, saves lives, reduces child mortality, frees up resources. It's foundational.
And it's climate resilient too. That's key. It's a passive system. Doesn't need a constant power supply, not much complex machinery that can break down.
So power outages, supply issues, less of a problem.
Much less. No long treks needed, no expensive maintenance really. It's a decentralized kind of solution. Empowers communities, builds resilience against climate shocks.
And for you, listening at home, even if you have reliable tap water now, innovations like this, making water more accessible globally, it matters. It could eventually mean lower costs, maybe, but definitely a more secure water future for everyone.
And the urgency. Why now? We mentioned the 4 billion facing scarcity. But climate change is making droughts worse. Populations are growing. Pressure on water is immense. We desperately need new, sustainable ways to get water that don't drain our planet or need massive, costly infrastructure. Fog harvesting fits that bill. It works with nature's cycles.
Yeah, especially for those remote, underserved communities where the usual systems just aren't there or don't work. This kind of low-cost, low-energy solution, it really could be life-saving. It's not just about water. It's about dignity, opportunity, freeing up time for education, work, life.
The researchers are definitely hopeful. They want to move towards mass production.
Yeah.
Making it scalable, affordable, worldwide. That's the goal. Of course, going from lab prototype to widespread use. It takes time, investment, more field testing in different climates. They're looking at better materials, modular designs to scale it for different needs. But the path is there.
The promise is just huge, though, isn't it? Taking inspiration from a redwood tree, a musical instrument, and creating something that tackles one of our biggest global challenges, access to clean water. It just shows you. Sometimes the best ideas are right there in nature, waiting.
So that wraps up our deep dive for today. We've looked at how scientists are, quite literally, pulling water from thin air, using this incredible mesh harp design inspired by nature and music.
And the key things to remember, that huge jump in efficiency compared to older methods. The really significant environmental plus is non-polluting, sustainable. The public health benefits, providing safe water, and its potential as this climate-resilient, passive solution for communities facing water stress. Yeah, it's truly incredible stuff. The ingenuity is just, wow. Simple idea, powerful result. So I'll leave you with the thought. Imagine that future. Clean, safe water, not scarce, but harvested from the air around us. How could that fundamentally change things for societies, economies, daily life, maybe even for you, closer to home? Think about it. And hey, if you found this deep dive interesting, do us a favor, hit that like button, subscribe if you haven't already, and definitely let us know in the comments what other science breakthroughs, what other topics should we dive into next. We love hearing from you.